Hello friends, welcome back to another video. This video is part of the series of videos on learning basics of programming. So today we are going to talk about writing our first program. I'm going to go ahead and create the Hello World program again. We already saw the Hello World program in one of our previous videos. So uh, I'm going to go ahead and create a new project in the code blocks. So when I go ahead and create a new project, I should be able to see different types of projects, and I will go ahead and create a console application project. So before I do that, let's talk about what is a project. So in real world, you will be writing complex programs. They will involve a lot of code. You will typically not never write all the code in a single file. You will have multiple files. In addition to code, you might have other resources, other stuff in your that will be needed by your program. So for example, you might have resource files for localization, for translation of content in different languages. You might have images, you might have a few other things, you might have configuration files. So all these things come together to form a project. So project is basically a way you will organize your program, how you will organize your files. It helps you to write and organize complex programs or complex applications, and there can be different types of projects. You can consider these types of projects as templates. So for example, I'm writing a console application, probably the simplest form of program, a command line application. But I could write a more complex program like a DirectX or a game DLL, or I can write just a simple DLL that might be a simple library which might be used by other applications or other programs. So these templates provide me a way, or these project templates provide me a way to write these different types of programs. This project template would probably have the basic building blocks of these type of programs. For example, DirectX project might actually come up with a default set of files that will help me to get started with writing a DirectX program. Console application just has a single file with a main function in it. So yeah, projects are really kind of a template, so I mean to say, let me rephrase it, that these are the project templates, and projects are a way to organize your program. So let's go ahead and create a console application. I'm going to click on go, and once I do that, I can click on next. I'll select the language as C++. I'll give it a name, so let's say first program, and let's click on next. So I think I already have a program, or I already have a folder with this name, so I'll just say first program 2, and let's click on next. Select all the default options. We are using the GNU GCC compiler. We talked about the configuration of this in the previous video. So I'm going to just go ahead and click on finish, and the project will create some default file main.cpp for my console application. So let's talk about what is there in this code. This will be a short video. I just want to have this as an introductory to this code. In the next video, we will talk about a few other things like variables, data types. But for now, let's just talk about what is there in this program. So I see a hash include IOStream. I see using namespace std. We see int main with the curly braces, with round braces opening and closing round brackets, and then we see a curly brace opening. Then we see cout, a couple of opening angular brackets. We see hello world in double quotes. Then again couple of angular opening brackets. We see end line, we see a semicolon, and then we see return 0, semicolon, and a closing angular brace. So what is actually happening here? So let's first talk about int main. Just forget about this couple of lines. Let's just talk about int main and what is this. So let me give you an example of probably a machine in a real world. So I make a machine that cuts apples into different shapes, and I have basically that machine has three functionalities. First is to cut the apple into a square shape. The second functionality is to create it into circle shape, and another functionality is to cut the apple into a triangle shape. So we can call that these are the functions of that machine, and I have, let's say, three buttons in the machine, and I press button 1 to trigger the function to cut the apple into square shape. Another button I press to trigger the function to cut into circle shape, and I press another button to trigger the function to cut that apple into a triangle shape. So we have the machine, we have the functions of a machine, and we have a way to trigger those functions or invoke those functions of that machine. Consider the application in a very similar way. And a program is like a machine, and it does some functions, right? It has some functionality, and basically it does some functions. So a program literally would have functions. So this int main is a function. It's the main function of the program, and a function does some tasks. So int main is like a special function in C++. It's the function that is invoked whenever the application is executed. So whenever I run my exe, so whenever I run this, I think this is the old program. Let me just clear the contents and let's do a build. I might have my old project console application running somewhere, so I'm going to close that and I'll just do a build. And if you see, it actually build this into first program 2.exe, and whenever I'm going to run this first program 2.exe, my main function is going to get invoked automatically. I'm not actually explicitly invoking it. It's going to get invoked automatically because it is the entry point of my program, and then whatever code I've written would be the processing that my function does. So in case of my real world machine, when I press a button 1, the processing that it does is it cuts the apple into square shape. In my case, my main function, the processing it does is just print hello world. So a function would typically have a main, have a name, like in this case the name is main. It would have a return type. A function can return some output, right? So it basically specifies what type of output it returns. So it could be void, and in this case it means that it's not returning anything. And if I try to return something, I would probably get an error. It could be int, like in case of int main, and here I am returning 0. This doesn't like have much meaning for me or for my program, but it return 0 kind of indicates like success, that the program has successfully exited. And a function could take some input. So this round braces basically specify or our placeholders or are basically the place where we will specify the input for this function. At this point, my main function does not take any input. It could take some input in subsequent lectures. When we talk in more detail about functions, we will see how a function can take input. But this is like a very simple function. The entry point for a program, it returns integer output, and it doesn't take any input, and the name of this function is main, and all the processing that this function does is between these two curly braces. Now let's talk about what's happening in our function. So we have a statement called as cout, and then a couple of angular opening braces, and then we have some text which says hello world, static text I will call this, and again couple of angular braces, and then angular brackets, and something, another statement, end line, endl, and then a semicolon. So cout is a statement used to print something to the screen. Now this statement is defined in a library. So typically what's actually is happening is that I'm saying cout. Cout knows that first of all, cout will know that there is an output device, which is my screen, where something needs to be printed. So cout will take this hello world text, and it will print on on the screen. Now cout might be doing a lot of things. It might be internally understanding what is the default output device. In my case, it's my display monitor, but it could also be a printer, it could be a projector, it could be something else, anything else, right? So there might be a lot of code written by someone for this cout statement, so that I don't need to rewrite a lot of code, and I just call cout. I just use this cout statement, and in a single line I'm able to print hello world on the screen, right? So this cout was written by someone, and it is defined in a library called as iostream, input output stream. This library has a lot of pre-built functionality related to input output. I could also be writing to a file instead of the screen. So this library actually has that functionality. So we include this library by saying hash include iostream. Now this using statement std has another like it's part of another step for including this cout. So let's say I am in a good mood, and I write another library which opens a browser, and I also define the cout statement in there. So and I include that library. So let me do this. You know what, I will say I'm going to comment first of all this line, and this angular brackets basically this forward slash basically indicate that I'm commenting this line. So what it means is, when the compiler will convert my instructions in the program into machine language, it will actually ignore this line, because it is a comment, it's not actual code. So the forward slash indicates that I am actually putting in a comment, it's not a code. So for now I'll just comment this line. Let's do a build and let's see what happens, right? So cout was not declared in this scope. So it kind of gives us a hint that this namespace is actually defining a scope for cout. And coming back to what I was saying, that I created a library, right? So I say my library is hash include mylib1, and I defined a cout in here, right? I defined the same a statement with the same name, cout. So now what is going to happen is there will be confusion. Which cout does this refer to? Does it refer to the cout from the iostream, or does it refer to cout from mylib1? So namespaces will help us avoid this kind of name collisions. So I could actually do this now. I could say std cout, std endline, and this basically means that I'm using the cout uh, from the std namespace, and this std namespace is defined in my library iostream. If I would have had something defined in my lib1 and I would have defined in another namespace, typically we try to define create namespace to have like unique names. It would be like a general the general guideline is to like use something specific to your company, like a domain name or some copyrighted name. So let's say I have my I know that my lib1 is a unique name, or lib1 is a unique name, so I would have defined a namespace lib1 colon cout, and since my cout opens uh, a browser, so I'm giving output www.c++.com. I say open the C++ in the browser, right? So just giving like a hypothetical example of how this namespace helps in avoiding name collisions. Since I don't really have a library, I'm going to just remove these lines. So I will just build this here, and you can see that my program should compile successfully. Now I'm going to go back to using namespace std, because I don't want to keep on writing std colon colon everywhere. It's just a short form, and I can do this because I know I don't have any other library which has defined cout. There is only one library at this point in my program which has defined cout. But like I said, namespaces are useful to avoid name collisions. If ever you come across a scenario where you are using two libraries and they both have stuff defined with the same name, so you would use the namespaces to avoid name collisions. Now one last thing is the end line. So let's do this. Let's explain what is this end line. And this endl or end line is again defined in iostream. So let's do this. Let's define hello world. I am on the next line. Okay, I don't necessarily need to define end line again. I'm going to build this again. Let's run this, and we should see hello world, and I'm on the next line. All looks good as expected, right? Now I'm going to close this program. I'm going to remove the end line, and let's build this program again, make sure there are no errors, and let's run this and let's see the output now. Let's see what's happening. So we see hello world, I am on the next line, but it's not really on the next line. So this kind of would explain what endl does. Endl would actually press an enter key so that anything that I do a cout will come on the next line. So going back to my window, I'm gonna close this, run this again, and build this again, and I'm gonna run it again one more time. And let me bring it in front, and we should be able to see the program hello world, I'm on the next line, and this all is like coming on the next line because of our end line statement. So I think we covered almost every element of this program. It's a very simple program, but I think it's a good start to understand or begin with coding. In the next lecture, I will get started on variables and data types. My plan is to have small lectures, small videos, and first define the basic elements of C++ programming. I mean, it's not necessarily C++. Same concepts will apply in other languages as well. But it is important that you spend time on understanding these basic concepts, because once you grasp these basic concepts, they will go a long way in helping you to write larger and more complex programs. Thank you. See you in the next video.